latest, hottest new version of thinking about the evolution of reciprocity, what is now called neuroeconomics, which is the whole notion of studying the brain imaging of people while they are going through the process of playing one of these game theory games. Putting somebody in a brain imager, and there will be some little computer console where they can press the cooperate button or the defect button, and imaging what parts of the brain are having increases in metabolism while they're playing. One of the first versions of this, a wondrous study, looked at people playing the grandparent of all game theory games, playing Prisoner's Dilemma, and looking at metabolic activity, excitement, activation in different parts of the brain. And what they discovered was something real interesting. Remember back a gazillion lectures ago, dopamine, a neurotransmitter of pleasure, of reward, of anticipation. When did those dopamine pathways activate? By all logic of humans as mindless, gleaming machines of rational economic choice, when should those dopamine pleasure pathways light up? When the opponent has cooperated and you've cheated against them, you've gotten 5 points, they've gotten 0. That's not when the dopamine pathways lit up. In this study, they became their most active when both of you were cooperating. Isn't that interesting? This part of the brain doing something wildly economically irrational, getting most pleased in the metaphorical sense with cooperation, not with cheating. Isn't that interesting? Another version of this, another one that comes out, is looking at the brain basis of resisting temptation. Now, how can we frame this temptation? What we saw in Prisoner's Dilemma is there's this temptation to cheat right now. In the long run, it's not worth it, but right now it's this temptation. What's the brain basis of resisting temptation? And here's sort of a classic economic scenario. What you've got are two choices: work versus reward. You can do 1 unit of work and get 1 unit of reward. Or a little bit later, if you're willing to do 2 units of work, you get 3 units of reward. Aha, if you're only disciplined enough to hold out and do the harder thing, do the 2 units of work, you're going to get a greater reward in the long run. When is the brain least able to resist the temptation of going for the cheap, fast payoff? Suppose the cheap payoff comes 4 weeks from now, and the more disciplined, higher payoff comes 4.5 weeks from now. Anybody can resist the temptation there and hold out for the tougher, harder, but better choice. And what you see is the frontal cortex, that area of the brain that does this gratification, postponement stuff, doesn't have to get very active to make that choice.